Right, so on this question, question 13 on the assignment, the question is about producing a neutral sample of lithium chloride from lithium carbonate and hydrochloric acid. So the first thing to think about is exactly what else is going to be produced. And I find that it helps me to to write down the equation. Unfortunately, this is not the first time I've done this. So there is also a load of other writing on this because my iPad managed to lose the first video that I made of this. So what you will get is if you have lithium carbonate plus hydrochloric acid, remember that anytime an acid reacts with a carbonate, it will produce a salt, water and carbon dioxide. So that's what we're getting here. And the salt in question is lithium chloride. It takes the lithium, the metal from the carbonate, and it takes the other ion from the acid. So it would be lithium chloride. Then you will also have carbon dioxide and water. So that will be your equation for this situation. Hopefully you can actually see this the correct way round, because when I'm looking at it, it's actually reversed. So I'm looking at it in mirror writing, and hopefully you won't have to. So we've got lithium carbonate plus hydrochloric acid gives you lithium chloride plus carbon dioxide plus water. Now, what we actually want from this situation is the lithium chloride. And we need to make sure everything else is gone so that we can just have lithium chloride. Now, carbon dioxide will be released as bubbles. Okay, so that one will be released as bubbles. Excuse my bubbles, they're absolutely rubbish. So the carbon dioxide we don't have to worry about. It's going to be released as effervescence, and on the plus side that shows us when the reaction is happening as well, because it's bubbling. Water we don't have to worry about, because water is something that solutions are dissolved in anyway, so we don't have to worry about water. The lithium chloride is dissolved in it. Another thing that you can do to get rid of water would be to evaporate it, and that would be at the very end of a practical. Like if they wanted you to get a solid sample of lithium chloride, you could evaporate it from the water. So we don't worry about the water in this case. But the things that we worry about is the lithium carbonate and the hydrochloric acid. What we've got to think of, which one is easier to separate away from the lithium chloride? Hydrochloric acid is a solution as well. We know that lithium chloride is a solution because it says a neutral solution of lithium chloride. Both of them are substances that dissolve in water, so they're going to be pretty difficult to separate. Lithium carbonate, on the other hand, is shown as a solid, so that is a substance that is a solid there. It is a lot easier to separate a solid from a solution than another solution from a solution. Now, the reason that that's important is because when we mix two substances together, it's actually very difficult to make sure that they are mixed in very perfect quantities. And at some point, when you mix two substances like this together, one of them is always going to end up in excess. One of them is going to end up with a little bit left over at the end. So what we do is we make sure that the one that's in excess, the one that there is lots of and that we will have left over in the end, is the one that's easiest to separate. Okay, and that is the lithium carbonate, because it's easier to separate the lithium carbonate from the lithium chloride than it will be to separate hydrochloric acid from the lithium chloride. Separating two solutions from each other is difficult. Separating a solid away from a solution is easy. So what we want to do is we want to make sure that there is no hydrochloric acid left at the end, and to do that we use excess lithium carbonate. Okay, and that's a really key thing when you're answering these sorts of questions, is to say use excess lithium carbonate. What that means is you get your hydrochloric acid and then you keep adding lithium carbonate and stirring, and you see all these bubbles coming off it. That's the carbon dioxide. All of these bubbles coming off it. And when eventually the bubbles stop coming, if you keep on adding the lithium carbonate, eventually it will stop reacting because there's no more hydrochloric acid left for it to react. So at that point, when you add some more lithium carbonate and nothing happens, at that point you know that the acid has all run out. And so you get rid of the hydrochloric acid by using excess lithium carbonate. And now what we've got left is we've got the lithium carbonate, we've got lithium chloride, and we've got the water that we don't really need to worry about. This one is a solid, and so to get rid of it from here, all we have to do is filter this away, and now we have no longer got lithium carbonate either. So hydrochloric acid in a beaker, add excess lithium carbonate until all the acid has been used up, to prove that all the acid has been used up, and then filter away the excess lithium carbonate. If you then want to get a solid version, the solid lithium chloride, then you can also get rid of the water by evaporating it, and you'll get crystals of lithium chloride at the end. But in this situation, all they want is a solution of lithium chloride. Therefore, you don't have to worry about getting rid of the water. So hopefully that makes sense, and hopefully this video will be able to be uploaded on there as well without deleting itself. So thanks.